Good afternoon. Last time we have seen several questions based on the asymptotic notations and the time complexity. Today we will cover some more questions based on these topics. So just see the next question. Which of the following option provide the increasing order of asymptotic complexity for these functions f1, f2, f3 and f4? So these are the functions in terms of n. We need to provide the increasing order of asymptotic notations in terms of tied bound only. Okay, so f1 is equal to 2 raised to power n, f2 is equal to n to the power 3 by 2. Okay, f3 is equal to n log n base 2, and here n to the power log n. Okay, now just consider this. Compare f3 and f4. Here n multiplied by log n base 2. Okay, and here n to the power log n base 2. So definitely n to the power log n base 2 will be larger because it is an increasing in terms of n. Okay, if you consider this f2 is equal to n to the power 3 by 2 means n to the power 1.5. This 1.5 is a constant. Okay, so if I consider the power of n here, so in f2 the power of n is 1.2, in f3 the power of n is 1, and in f4 the power of n is log n base 2. Okay, so which these f2 and f3, these are constant power of n. N is 1, the power of n is 1 in f3 and the power of 1.5 in f2. So which one is larger while comparing f2 and f3? If I compare f2 and f3, then f2 is larger, and if I compare f3 and f4, then if I compare f2 and f4, then f2 is smaller because this is n to the power half only, and it is n to the power log n. So if the value of n goes on increasing, then you will get larger value, larger power in terms of n only. Okay, so the smaller thing, this f3 will be first one, then after that this f2 come into picture, after that f4. Okay, and all these f2, f3 and f4, these are nothing but polynomial functions. Okay, and if I consider this f1, that is 2 raised to power n, this is the exponential function. Okay, just compare once f1 and f4. In f1 it is 2 raised to power n, while in f4 this is n to the power log n base 2. Okay, while comparing f1 and f4, which one will be larger? This is 2 raised to power n, and this is n raised to power log n. Okay, if I just compare the power, then the first power is n and the second power is log n. So this f1 will be larger. Okay, so the correct option is this: first f3, then f2, after that this f1 come, and then finally f4. You can take one example, like suppose the value of n is 16. So this will become, f1 will become 2 raised to power 16, and f4 will become 16 to the power log 16. Log 16 is nothing but 4 only. So here one is 2 raised to power 16 and second one is 16 to the power 4. Okay, so this 2 raised to power 16 can be written as 2 raised to power 4. So 2 raised to power 4 to the power 4. Okay, that will become once again 2 raised to power 16. Okay, if I just increase the value of n once again, if the value of n is equal to 32, then f1 will become 2 raised to power 32, whereas this f4 will become 32 to the power 5. 32 can be rewritten as 2 raised to power 5, where 2 raised to power 5 to the power 5 is nothing but 2 raised to power 25. Okay, So 2 raised to power 25 and here 2 raised to power 32. Okay, just compare one more term in terms of n. If the value of n is 64, then this f1 will become 2 raised to power 64 directly, and f4 will become 64 to the power 8. 64 to the power 8. Okay. Then 64 can be rewritten as 2 raised to power 6 is 64 to the power 8. So 2 raised to power 48 is there. Now compare f1 and f4. Here the value of f1 is larger as compared to f4. Okay, so the correct option is A, F3, then F2, then F4 and F1. The final option is A. Just consider this next example. Here Fn to the power 2 raised to power n, g of n is equal to n factorial, and h of n is equal to n to the power log n. Which one of the following statement about the asymptotic behavior of f of n, g of n and h of n is true? Just compare this first. This is n raised to power log n, okay, and it is nothing but 2 raised to power n. We already compare this 2 raised to power n and n raised to power log n. This f1 is 2 raised to power n and f4 is n raised to power log n. So among these f1 and f4, this f1 was larger. So definitely this 2 raised to power n is larger as compared to h of n. So what is the relationship between f and h? F is larger, so h of n can be said as order of f of n. H of n is nothing but order of f of n. That is correct. Where you will get this? See in equation 3, this is h of n is order of f of n. Okay, so this is correct. Option A and B, these are wrong because here it is saying that g of n is order of h of n. This is wrong. Now just see the counterpart of this. G of n is order of h of n. G of n is order of f of n. Compare G and f. So here n raised to power n is there. So g of n is order of f of n. That is wrong because this is 2 raised to power n and this is n to the power n. Okay. So this correct option is g of n is larger as compared to f of n. So g of n can be rewritten as omega of f of n. So the final option is D here. You can note here h is order of f because h is smaller and f is larger. This g is omega of f, so g should be larger, and f should be smaller. Okay, so the correct option is D here. Now see the time complexity of the following C functions. Assuming n is greater than 0. Okay, this is a recursive equation. If n is equal to 1, then return 1. Otherwise, it is a recursive call, and what it is called here, recursive n minus 1 plus recursive n minus 2 is called here. Okay. So the option is that order of n is the first option, second order of n log n, then order of n square, and finally order of 2 raised to power n. See one hint is there. You can solve these questions without looking at this particular function also. How you can solve this? Suppose see, if just assume that the square also, and 2 raised to power n is larger as compared to n square. So I can take this also order of 2 raised to power n because n square is also providing upper bound, and as n square is also providing upper bound, 2 raised to power n definitely should provide an upper bound. Okay. So here the correct option is order of 2 raised to power n only. Okay. If the correct option is 2 raised to power n only, then I have to take this 2 raised to power n only. I cannot take this a, b, or c. Okay. Now, if you expand this equation, this recursive call, just consider the value of n is equal to 4. See, if it is a recursive 4, then you will come here. This condition is false. Then you come here. It is recursive 3 plus recursive 3. Okay. So this is recursive 3 plus recursive 3. Okay. Once again, this recursive 3 is called here. Then recursive 3 will end up in recursive 2 plus recursive 2. So this is recursive 2 plus recursive 2. Here also you will get the same scenario, recursive 2 plus recursive 2. However, recursive 2 is once again decomposed into recursive 1 and recursive 1. When recursive 1 is called, this 1 is collected into n. Now you are saying this n is equal to 1, this is correct, and this time you will return 1. Okay. So recursive 2 is decomposed into recursive 1 and recursive 1. This recursive 2 is also decomposed into recursive 1 and recursive 1. Finally, the same structure will come here.